Hello everyone! We will do a fun and simple experiment and explore the science of crystals that can be found at home. We will compare the crystals through different tests to see how similar or different they are. What we'll need for this experiment is salt, sugar, alum, 3 clear plastic cups, construction paper, masking tape, a marker, cotton swabs, and dirty water. Come on, let's get started. First, let's try to differentiate salt, sugar, and alum crystals by dissolving them in water. Use masking tape and a pen to label 3 cups as salt, sugar, and alum. Place half tablespoon of salt, sugar, and alum into their labeled cups. Next, add 2 tablespoons of room temperature water to each cup and swirl for about 30 seconds. Swirl the solutions for another 30 seconds and check which cup has the most dissolved crystal and the least. Observe the solutions. Did you notice any differences in the amount of crystals that dissolved? Almost all of the sugar dissolved in water. Some salt and alum, however, were left undissolved in their cups, but there is more undissolved alum left. Next, we'll explore the evaporation of our crystal samples. Using the solutions from the earlier activity, put salt, sugar, and alum solutions on black construction paper and let them dry. Use a cotton swab to place drops of each solution on the black construction paper, and then we will wait about 20 to 30 minutes for the water to absorb and evaporate. Now let's check the results. As we may observe, the salt solution left tiny white crystals. The sugar solution left a dark spot but no visible crystals, while the alum solution left a lighter spot than the sugar, but still no visible crystals. Now let's see how salt, sugar, and alum react when we mix them with dirty water. Fill 3 labeled plastic cups with 3/4 full of water and then add dirt to each cup and stir. Each cup is now filled with dirty water. Then, we will add half teaspoon of salt, sugar, and alum to each cup. Then we'll stir the solution and let them sit for about 15 minutes. Now let's check the results. The salt and sugar cups still look dirty, but the alum cup is visibly clearer. This happens because alum has the special property where it clumps dirt together, making them heavy enough to sink. That's why alum is often used in water purification. Through this experiment, we saw how salt, sugar, and alum behave differently. I know you are curious, so let us answer some of your questions. First, why the different amount of salt, sugar, and alum dissolve in water? The answer lies in the differences in solubility. For a liquid to dissolve a solid, the molecules of the liquid and solid must attract one another. Sugar dissolves almost completely in water because of its polarity and strong hydrogen bonding with water molecules. Salt, on the other hand, has moderate solubility as it dissolves through ion-dipole interactions but may leave some undissolved residue if too much is added. Alum, however, has the lowest solubility among the 3, so a significant amount of it remains undissolved. This difference in solubility explains why there is more undissolved alum left compared to salt and why sugar dissolves almost entirely. Second, why did crystal solutions look different after evaporation? Salt forms tiny visible crystals because its ions rearrange into a solid structure after water evaporates, whereas sugar doesn't form crystals because it holds onto water molecules, which makes it difficult for the sugar to crystallize. Lastly, alum only left a faint residue because of its hydrated structure, which allows it to contain water molecules even when dry. Third, why did alum make the water clearer? When water was mixed with alum released aluminum ions in water, which attracted dirt particles and made them clump together. This process is called coagulation, where larger clumps become heavy and sink to the bottom, leaving the water clearer. This is why alum is often used in water purification to help remove impurities. In this experiment, we have explored the solubility, crystallization, and coagulation properties of salt, sugar, and alum. Even though salt, sugar, and alum may look similar, their chemical properties vary. Chemistry helps us understand these everyday materials in a whole new way. Thank you for watching, and we hope you learned a lot from our experiment.